Up, up. Let's settle. Does this camera work? Yeah, both of them work. So let's wait until the audio is there so I can confirm it, and then we can talk about the USB hub, which has been quite a while since I've talked about it. So here is the data. Yep. Here's the latest prototype. Well, prototype. It's not a prototype anymore. Quick recap. Why I'm designing a USB hub. So you have plenty of videos to see the progress, but I did design a USB hub, and I wanted an industrial USB hub with several criteria I couldn't find in other hubs. First, it would be higher quality, so you have input capacitors, proper input and output capacitors for the power, so it's smoothed out. You have ESD protection for input and output, so this way if anything happens to one port, it doesn't affect the other ports, and it doesn't go upstream. What else? Yeah, current protection, input current protection, so the hub cannot take more than 500 milliamp. And this is USB 2 specification, and I only want a USB 2 hub. I don't need any USB 3 or USB-C hub. It's plain old USB 2 hub. But the most important part would be that I can control all the power or the ports. I wanted a flat USB hub, so 7 ports in one hub and not 2 times 4 port, which you see very often in 7 ports hub because it costs less. And I need that because I have plenty of devices and I cannot cascade anymore the USB hubs. You can only have a depth of 5 or something like that. So you can only have one behind another 5 USB hubs. And if you have a 7-port USB hub where the 4 other ports are yet another branch, it takes 1 node less. So this is a flat 7-port USB hub. Then I want it to be the ports, the output USB ports, you can control the power individually, remotely, using USB. This is in the USB specification. You send a signal and say, please power off this port, please power on this port, and so on. This works. I wanted also to have overcurrent protection on each of the hubs. So the idea is that I use the USB hub, this is the final form now, I use the USB hub for testing devices. So production testing, and I know that the USB devices are should be USB 2 compliant and should not take more than 500 milliamps. So if I plug something in and if it takes more than 500 milliamps, I want this to be protected. This allows that only one port gets shut off and not the whole USB hub, because if you don't have any current limitation, it will suck out of all the power out of all the USB hub, probably resetting the other devices which are connected on the other port because they get less current, and even the USB hub. So you can reset the complete USB hub. I don't want that. I want the USB hub to stay alive even if there is a faulty device. So it protects against ESD and against overcurrent protection. So that's done. And finally, I want it to be, since I control power, I just don't want to control 5 volt because 5 volt, 500 milliamps, some of our devices, production devices I want to test, take more of that. They take more than that. So what I do have is these barrel jack connectors, which allow high power, something between 6, actually, so it's here it says 6 to 40 volts. It's actually 5, but it's just to be sure. You have a different 5 volt input. So yeah. So on these ports, the same than here, I can control if power comes out or not, and this way I can power a larger device, something which takes 12 volt, 24 volts, something like that. And this is not current limited. So here is the input, USB type B, the large one. Here is the 5 volt input because this is limited to 500 milliamps, and I still want to be able to provide 500 milliamps on each of the ports. But this is not possible using this input. So you have an auxiliary input, the 5 volt input, which allows to provide 5 volt to each of the ports. And actually, if you plug the USB hub in the computer without having the 5 volts, so just using the USB port, it will tell that it doesn't have enough power to provide enough current for all the things. I can test it actually. Let me show it to you. So how it works. I just have to plug USB here. Journal control minus, do you see? Yeah, oh, you actually see it also. So here's the journal control. Now system control connecting, and I should be back. Yeah, audio is back, and now we're back. So I just had to use the other network card. Since it's been a long time since I did a stream. So if I plug this USB hub, you will see that it is a flat 7-port hub. You see here, 7-port hub, and it says insufficient power available to use all downstream ports. So in USB, the upstream port is the host, and the downstream port are the devices. And you see here downstream facing port, which you see here. So because we only have 500 milliamps going here, and this is limited by this fuse, I cannot provide 500 milliamp on each of these ports. This is why I have an auxiliary 5-volt port right here. So you can plug the 5-volt here. But I also have the 6 to 24 volts, 6 to 40 volts. This is actually mainly for 12 volts input. Sorry, I have to sneeze. No, okay, I don't. So this is mainly the 12 volts. And on here, I have a step-down converter, which converts this 12-volt port into 5 volts, which generally, in theory, if you want to plug 5 volts here, you need to plug 7 times 500 milliamps, so that's 3.5 amps, and it's not usual to have a 3.5 volt amp power up to 3.5 volt amp power plug. But it's you can find it very often on 12 volt, and on 12 volt, since it's down converted, you don't need 3.5 amp, 2.5 amp is plenty enough. So here I have 12 volt input, here I have a 5 volt output regulator, which can do 3 amps, so it can power all the things. And also the power which is here will be provided on the output here. So the idea is I plug 12 volt in, the 12 volt provide the power for all downstream facing ports and to this high voltage output, which I can then control the production device. And the idea is that I plug production devices, and in my test script I switch all the time on and off the device because I need to reset it after flashing, after some tests, to do some resets and so on. To have a clean state, you just power on and off the devices, and this is what this is meant for. So you can power off the 5 volts and the 12 volt at the same time, completely switching off the power of the device to be tested and then powered on. So this is the idea of my industrial hub. Let's go through the versions first. I had this one, which is too small. I wanted it to fit in a smaller case, but the problem is that it is cramped, and there were several issues. Then I made the second version, which looks like this, and actually it kind of works. So this is the demo. At least USB worked on here. The power management didn't work well, but the USB worked. I made this version, so this is version 0, this is version 1, and on this version it almost was complete. So power worked kind of with some details which we'll talk about, and then the USB worked also. The problem I had is the overcurrent protection on the downstream facing ports. I used a fuse in the beginning, and this fuse was just too slow, and so it's a PPT fuse like I use on the input facing, so this polyfuse. And the polyfuse are useful because they can reset easily, and they're easy to use. And I added it on the outside. The problem is that they're very slow to trigger. Something depends on how much current you're using, but it could be 1 second. This is too slow. So I've added a current limiting device, and this was really a pain finding the right current limiting device. So you have a small chip. Let's zoom a tiny bit. It's this one. Yeah, it's this one. This one limits the current. So whatever, it doesn't trigger if you take more than 500 milliamps. So it doesn't cut off, which the Polyfuse did. It will limit at 500 milliamps. So the voltage will decrease. If you try to use more than 500 milliamps, it will just decrease the voltage and it will always just take 500 milliamps. It will also signal the USB hub that this port is in overcurrent condition. And the USB hub can either report it back to the host, but actually this one kind of, it's hard to say that it doesn't. It does if it doesn't reset, because in this case, it will try to power on and off the device all the time, automatically. This is not something I can change. And when it powers on and off, well, the overcurrent is kind of cleared, so it will not report it back to the host. But the chip provides this information, so if it doesn't trigger on and off all the time, it could report back and says there is an overcurrent on port 7. And I tried, it also works. In this case, I tried by forcing it, it also works. In this case, it won't work because it will trigger all the time, and we'll test it. I'll show it to you. But the problem with this chip, it was such a pain. Let me find the ones I was using. So, USB hub, datasheet, I used several of them. First, I used the Polyfuse, which just, let's switch the screen. Full screen, this one. So the Polyfuse, here little fuse, PTC, these are the Polyfuse. This is the first thing I've tried. And here normally you have a curve how fast it triggers. No, this is how fast to reflow. This is reflow. Isn't there a curve for the response time? It's time, here, time to trip. You see, if I use 500 milliamp, this is probably here, 500 milliamp fuse, it takes, with 8 amp, it takes 0.05 seconds, but I'm not using 8 amps, so I have less current, so it takes a lot longer. It takes around 1 second. This is what I've measured. And normally, the data sheet should provide a curve. Here. Response time. Here we have the 500 milliamp, this one, this curve. If we just take 500, just take 1 amp, you see it takes around more than 1 second. It's this curve. Yeah, it takes a bit more than, so at 500 milliamps, it takes more than 1 second. So this is too slow, and I want to protect the device. So then I tried. We have plenty of current limits. I think I've started with this one. Yep, I started with this one, adjustable current limits. So it's good that this allows you to enable and disable the power, which I wanted, and also you have a pin which allows you to set the current limit. And this one was working fine, except I didn't have the overcurrent flag. So I didn't have the output which tells, this one is taking too much current, because I wanted that to either indicate to my OS that something was wrong, or to actually power on and off all the time. So I didn't use this one, but else it worked. As current limit, it does work. Then I used then I used this one, and I was a bit fooled. This one fixes it. Here you have an OCB, overcurrent signal, so it pulls it low when there's too much current. So I have this signal, and I've used this. You see 0.6 amps. So I think I used this version or this version, I don't remember. Active low. I think I used this version. So it's because I read 0.6 amp, I thought it would break at 0.6 amp, but that's not the case. If you look at the datasheet, so you don't have a pin which allows you to set the maximum current. It is fixed. And since it's USB, 0.5 amps, 0.6 amps, it's okay. But if you look in the datasheet a bit slower, you see that this version I have doesn't trigger at 0.6 amp. It triggers between 0.8 and 1.6 amps, which is far too much. So yeah, I didn't read the datasheet. I was fooled by the 0.6 amps. I don't know what the 0.6 means. I don't know what this means. This is not the one which, this is nothing to do with, I don't know. So, and every time I soldered correctly on the board and I had to wait for the next piece. Afterwards, I found this one, which was really nice because it had the two things. Where is the pinouts? Here the pinouts. Actually, this is another thing. So here you have enable flag, which the enable, so you can enable on and off. You have the limit, so you can set when the overcurrent protection triggers. And then you have the flag, which indicates to the USB controller or the USB hub that something is overcurrent. This was the ideal part. The problem with this one is, first, it doesn't have a pinout. It shows this, it doesn't tell on which pin what is, where it is. Oh, here it is. I think, yeah, I found another datasheet. On their website, there's no datasheet. Also, this one was faulty. So, where is this unit? Here it says we have in milliseconds current limit response. It should be more than this in milliseconds. Here output turn off, milliseconds, output turn off delay, threshold. So whatever. It's not important. Here, overcurrent flag response delay. Normally, if you do overcurrent within approximately 7 milliseconds, it should indicate that there is an overcurrent. And what I liked with this one is that, which is written somewhere, when it reaches the overcurrent, it will block the, so it will limit the current, and then it will limit to half of it when it's too much, which is kind of nice because it's even further limits the current and protects, which I liked it. And still you restart the device. But the problem is that this 7 milliseconds, this is not the case. It took over 3 seconds, and I probably have the picture of it. Pictures. No, I don't have overcurrent protection. Switch off. No, this is not the same. I have it short, maybe in here, where you can see it takes more than 3 seconds. That's not the one. Okay, this is something else. I have a oscilloscope pictures showing it. It took 3 seconds to trigger the overcurrent condition, and when it triggers the overcurrent condition, it goes to half of it, half of the set current, which is a nice feature. And the problem is it never set the flag. I don't know what they did with this part. It is completely faulty. I think what triggered was not, so it is a faulty part, and it's not just one. I've tried with around 10 of them because I didn't understand how it worked. And I think it's not just one. It's not this which triggered the overcurrent flag response. It was something else. It was the over temperature shutdown, because the chip was pretty warm when I touched it, and when I think it went into this mode, and then it halved the current all the time, but it never set the overcurrent flag. So this fault, in theory, this part is nice. In practice, don't use it. Also because the datasheet is really crappy. It doesn't give the dimension of this chip. Yeah, SOT25 and with 6, and then large or least. I don't. Probably this is least. Still, you have to provide the dimensions. You cannot just say SOT23. Sure, there are some kind of guidelines. You have 0.95 millimeters pin pitch, but it doesn't tell you the body of the width and so on. And also the pinout was missing. This is just a datasheet I found leaked somewhere. And yeah, so bad part. I was kind of disappointed, and also it took me a lot of time because I didn't understand what I was doing wrong until I thought the part is defective. And the last one I found, which is currently in here, it's this one. This one. So it has everything I need. It has the enable, either high or low depending on the model you're using. You have a limit which you can set using a resistor. You have an input and output, and you have a flag which is open drain flag. This is exactly what I wanted, and it worked from beginning on. So this is the one I'm using, and it took me forever to find this, and this is why I didn't make a video, because every time I had to order a new chip and test it, solder it on the board and test it, and this is the one we finally have. I still have yet a problem on my board. Let's see, board, let's see the schematic on the downstream facing port, schematic all. So this is the downstream facing port. What I've added between version 1 and version 2, so here at version 2, is that we have a current feedback protection from the voltage out. Not only that, I fixed a couple of power input protections and so on. So it worked correctly. And the setting and the detection works correctly. But previously, now the hub only gets powered when there is USB. If USB is not connected, the hub is not powered. So it will not power the downstream facing port and so on. I also wanted that whatever you connect, so this part here, which is now the current limit, also has a reverse current protection. So if there is power, if there is 5 volt from the device coming in here, if this is enabled low, then the 5 volt will not come through and feed the other ports. Sure, if the switch is enabled, the power will go through. If it's not enabled, it's blocked. And I wanted this current reverse protection also on on the high voltage output. This is what I've added here, so it only works, and this is faulty actually. The problem is if you have 12 volt here but not 12 volt here, so if you connect the downstream 12 volt but on the upstream you don't have 12 volt, then it feeds back. This is not switched off because you don't have the voltage on the input. This is here, the voltage target is not provided, so this is not pulled up. Because this is not pulled up, there will be some current going through this transistor, MOSFET, and then through this diode, and then it will power this device. And then there will be some current going here, but because it's already enabled and because of the body diodes, the voltage is low enough on this pin that this is continuously on. So if there is no voltage input, the power input will feed the other devices. So this is a faulty design. How I fixed it is that you need the resistor. There will be a resistor here directly only for this transistor. It's not controlled through this one. So the voltage, so by default, if you connect it here, this one is blocking. So there's no current, no reverse protection. This one is not blocking. Then it will go to this one. If the voltage target is present, then this is enabled. So the voltage is not reverse protected, but this is okay because we have a voltage input. The issue is that if the voltage output is higher than the voltage input, I still have an issue. But this shouldn't happen. It's just a limitation. I cannot protect against current protection against current input from the downstream facing port if the voltage is higher than the voltage input. If it is not higher, it is protected. So if the voltage on the input is not present, this will now block in the new design. I need to update it. This is something I did yesterday, and I'll show you on the camera afterwards. And then this one, which controls the power, which you see here, this one will also control this MOSFET and enable or disable the power coming in here. And so let's switch back to the bench. This is what you see here. There is an additional resistor, 2 additional resistors. So this voltage trigger controls now this PMOS, this MOSFET, the power controls this one. And you see it also on here. This is the budge I did here. I just had to manage the I just had to reroute the signals, but it works, and I can show it to you, and I will show it to you, and afterwards this is finished. So let me switch on lights, power, and so on. You can even see better. And if I provide, so let's check actually. I need here voltage. I will set, and I wanted to show you. I had a script which actually shows you the voltages. How did I work? How did I do it? I'm not using the thing anymore. It's a picture. I don't remember how I showed how I showed the things. So first I need to switch on this and this. Okay. Let me just enable my multimeter and my power supply, and so you can show it. Multi-dashboard, which it's been so long. Which was the script? OC capture, no, DP, IR, cam, UT, web. Did I do it in web again? Did I do it differently? Let me check my OBS configuration. No properties available. What is this? Maybe it's because it's broken. I know I've updated and I'm not using the web interface anymore. Or am I? Web.rb. I did write another tool. What? Request fail, input output error. Fuck. Okay, this script doesn't work. What did I do? Let me check. I think it will provide the website. I'll just do it this way. Web app. And on what port are you listening? 5000. So localhost 5000. A PSU is not on. Why are you not on? You should be connected. You should have power. Why isn't it working? Let's try to power on and off. Power supply. Ah, the script does it. It powers off. Okay, now it works. I'll do it this way because I don't remember. don't remember how I did it. What's the solution? So here you have the values in something which is not visible. I don't remember, I did something else so I didn't have to use the browser plugin. Okay, yes, you have the values here and you can see what's happening. So here we have 12 volts. On this plug we have 12 volts. If I power on the output, and if I take my multimeter, and you also should see, then we have this way 12 volts, this is 12 volts, and in here we shouldn't have anything. Yeah, we have nothing. So this is protected. This is protected even if the USB is off. If the USB is on, it is also protected. So up. Now the power output is enabled, but since there is power on the USB, but since there is no power on the input, we should also have still no power here. Yeah, 5 volts. This is something which is leaked back from the 5 volts. So, but there's no current in there. It's just a leakage current, because on how I set and how I detect it. So there's nothing which is, and also I don't, so there's nothing which is coming out here. Not a lot. Nothing we can damage. But if I go now on the inputs, then we should have 12 volt also here. Yeah, we have 12 volts. And if I switch it off, which takes a bit of time to fade because the capacitors are huge, you see it is fading. So this works. And I can also remote control power on and off these things. And this is and actually I have 3 of these hubs currently used. So one which is really used for my production testing, which is actually this one. I have one which is which is sitting right here. This is where all my bench stuff is connected to my computer, which is on the right. And then I have one directly on my computer, which I have all other peripherals like keyboard and so on. And yes, I don't need to use such a huge power for my computer, but again, I wanted ESD protection on all the devices, and I wanted to be able to switch on and off the ports on all my things. And it allows me also to use my USB hub, so I can really test if it works or not, and not just in theory. So I've been using them. So this one, this fixed one with the fixed overcurrent is the latest one. The other ones have overcurrent protection, but no signal going back. And this is the state of the USB hub, and this is finished. So I just need to update the datasheet, my schematic, to reflect this modification. But I won't do any other batch and so on. The only thing I will do, is update the schematic and the board so it's correct. I won't order any one of them because I have enough of the USB hubs now. And I will build a case. So it is huge. It is really huge. Yeah. But using all the power things, I think it's okay. I will just build so this will be 3D printed. So you see lots of inputs and output capacitors. You don't find them anymore in cheap USB hubs. So it's not really well regulated and so on. You have plenty of glitches. This is not the case here. You have also all kinds of protections. And with this, I have my industrial USB hub, which is finished. And took a lot of time, but I'm happy with it. I will just finish the case. So here there will be a 3D printed case, and on top of it I will just add plexiglass so I can see the LEDs, because the LEDs will tell if there is power. It will, you don't see it, let me show you. It will tell which speed it is using. So if the 2 LEDs are on, it's high speed. Up. You see the 2 LEDs are on, this means this is high speed. This is written here. If only the red is on, it's full speed, which is most of my devices. And, well, most of my devices, of the dev boards I'm using, they only have full speed. There are USB 2, but only full speed. And low speed is blue, but I've never seen a low speed device. I don't know if I have some. For example, your USB to serial devices, these are low speed devices. These are full speed devices, no high speed. So these are only not 480 megabits per second, but 11 megabits per second. And I think low speed is 1 megabit per second. I don't know. I don't know it. But here I have the status. I have the switch, so I can really force the switch off if I want to. You see the LED fades out, so there is no power going out. I can force them locally, and I can control it remotely. I can show it to you actually. I just need to find out which hub it is. How you do it is USB hub control. Hub control. Let's try if it found all of them. And I have one which is where only one port is connected. Power, high speed. It even indicates what port, but it's not port 7. So I am on port 5. Okay, none of them tell that on port what? 1, 2, 3. Which port is it? 1, 2, 3, 4. Ah, it's port 4. This is not this one. It's probably this one, but why? Ah, there's nothing connected to it. Okay, so it is this one, USB 1.3. 7 ports per port switching, power switching per port, power switching probably. Yeah, USB 2 only, not USB 3. See my logo, and I can control the ports individually. So let's try. It's port 4 on USB on hub 1.3. I don't remember how it worked. Let's switch this back here. So I think it's location, and I think it's 1.3 and then minus P for ports. Ports, it's port 4. And then I need action, it's off. And the power should be switched off. And you see it is fading. It is fading because there's no load. As soon as there's a bit of load, because there's a high capacity on the output, I think 150 microfarads. As soon as there's a load, it will switch off really fast. And if I switch on, it is switched on. The overcurrent is not, let's try the overcurrent as demo. It will not be indicated because there is the power control. If there would be no power control and if the USB hub wouldn't reset it all the time, it would work. And to show you, I need a power meter. Let's get a USB power meter here. This one. Up. So I need to power it remotely because I will switch it off. So here you see the power it's using. Here I have my electrical load. Whoop. And there's too much reflection this way. And now I can increase the current. And at some point you should see that this switch, this LED, power LED blinks, and that you don't have 5 volts anymore because of the current limit. And it should be around 500 milliamp. It's not exactly 500 milliamp. I think I've added a bit of margin. It doesn't work. No, it does. You see the voltage? No, it doesn't work. It doesn't work. I have 1 amp. It should be blinking. Maybe I soldered something wrong. Let me try on port 1. And why is it on if I switched it off? There should be no power here. This is switch off. And it should override. Oh, okay, so it's not as I wanted it. This is on. Okay, this port has an issue. This should, so let's try this one. The fuck? If there's a load, I cannot switch off? What is happening? If there's no load, it switches off. You see the power goes low. But if there's a load... Oh. This is injecting. Ah, this is because there's voltage input. Sorry. So it was taking voltage from this port. Okay. Okay. So let's try it again. And now it works. So this was injecting. So yeah, if it's injecting, I cannot... Oh well, I can switch off. So there will be reverse protection, but the LED will stay on because there is still 5 volts here. But there will be no injection. The switch is really switched off, so no voltage will be going through the other ones. So okay, let's try this one again. So this is off, and we see it is off. Let me switch to... Okay, we can still see. Okay, so here we have at 300, 400, and you see up, it triggers, and it's not reported to my computer. So you can normally in journal control you could have an information journal control. Where are you? Here, it doesn't say that there is an overcurrent protection. This is because the overcurrent protection the flag needs to be set for more than 1 second or something like that. But since the USB hub is always trying to reset this device, and you see it by the blinking of the green LED, so every 100 milliseconds, I think it's trying to reset to re-enable power to the device. And every time it switches off, it will clear the flag. So this hub has no way to know that this is there's a overcurrent condition. But you see, there's the overcurrent condition triggered. So normally the switch will limit the current, but because of how the USB hub reacts, it will power it off completely, which is a good thing. And if we go lower, I think I've set the limit at 400 milliamps, something like that. Let's try out. I've set it to, because I wanted it to be lower. Yeah, 400/70. I think this is what I set it to. And not 500. It's fine. This is, if you follow the schematic, there will be the right value. I just changed the value to be even higher. But yeah, and now it works again. So the overcurrent works. I just feel this is kind of stupid when you have, and this is a flaw on this USB hub. Maybe there is a register doing it, but it is not documented. There is no register which says keep the currents on if you find the over. Let me show it to you. Let's have a look at the data sheets. So you go back here. We don't care about you actually. Okay, you can go here. The data sheet of this data sheet here, full screen, and here are the configuration registers. No, these are the pins. Option LED mode. Yeah, LED. You have the overcurrent something. Let's try OCB, over OCS. I think they call it OCS, overcurrent sense. Where's the corresponding register? Here you can provide that there is overcurrent sensing. I can actually switch it off, but I don't want to. So these, okay, this is overcurrent delay time. This is something like that. Overcurrent gang, overcurrent sense. So yeah, in the bits, I do say overcurrent sensing individual port by port. And then the overcurrent timer, here, this one, you only have these values. So it means that, and I've set this one, so it means, oh, I don't remember. So the overcurrent from the datasheet takes around 10 milliseconds to be detected and the flag to be set. This is the overcurrent chip which does it. And then with this overcurrent timer, after 0.1 millisecond, it will switch off the port. I cannot tell it, okay, don't switch off the port and just tell me the overcurrent, but the hub keeps the overcurrent. And I cannot, okay, so this is even the last register. This is a pain. Maybe there's another register, maybe this bit is there to say, don't, and the overcurrent timer delay, this is not to say when it tells you that there's overcurrent. This is to tell when it switches off the port. This is really poor documentation. But I didn't find any better current sensing. Yeah, individual port by port, but that's it. There is no, why can't I continuous, okay. There is no bit which allows me to continue sending power, but I think it's okay. So I will, on my host, I will not see the device doing overcurrent, which is kind of a pain, but at least it is protected fast. And the main purpose was not to be monitored, but to be protected fast. And that's it. That's the hub. If I still want, I can solder some. I didn't completely. I could check because most of the parts could be placed from the machine. You still need to solder, so all the through-hole parts need to be soldered by hand. It could be doable. I could order, I don't know if there's any demand for it. It's for me. It's so I can do production testing of my devices. I'm sure other people would like to have a USB hub as powerful, maybe a bit smaller. I don't care if it's smaller. It's the size, it's not meant for desktop, it's meant for production testing. But I'll make the case, I will fix the schematic, and I will probably never order some machine placed. I just place it by hand. I will probably do a last one because I still have some boards left, but that's it. And that's it for the USB hub. I've talked far too long. How long? 40 minutes, yeah. I thought 1 hour was okay. And that's finished. The product is finished. Is it not public? You can find, I think you can find it online already. Git.qvoodoo.info explore board USB hub. So once I've updated everything, you will find the source code and the schematics and maybe not the exports. Yeah, maybe I'll make a release. If you look at releases afterwards here, you probably find the USB hub version 2 release. I'll probably make the printed case first. The case printing. Yeah, I'll probably make the case, the 3D model of the case, and then add it also. I'll add it afterwards. So yeah, I'll make that in the next days to complete the project, and I'll upload everything here. And that's it. That's finished for the USB hub. I will make another stream where I will build some other random funky device, but that's for afterwards. I'll have some lunch and probably I'll see you in 1 hour or so for the next stream where I build a silly gadget, which I will not spoil yet. You will see it afterwards, but that's it for now. So yeah, enjoy.